Hey there, nature lovers! Today, we're diving into the fascinating world of insects, specifically the Tapinoma sessile, also known as the Tapinoma sessile. The Tapinoma sessile is a species of ant that belongs to the Formicidae family. These ants are commonly found in North America, particularly in the eastern United States. They're known for their distinctive appearance, with a dark brown to black body and a pale yellow head. These ants are social insects, living in colonies with a queen, workers, and sometimes males. They're known for their aggressive behavior, particularly when defending their nests. The Tapinoma sessile is also known for its unique nesting habits, often constructing their nests in the soil or under rocks. So, there you have it, folks. The Tapinoma sessile is a fascinating insect species that we can all learn more about. If you enjoyed this video, please give it a thumbs up, and don't forget to subscribe for more exciting insect facts. Thanks for watching, and see you in the next video. Tapinoma sessile is a species of small ant that goes by the common names odorous house ant, sugar ant, stink ant, and coconut ant. Their colonies are polygamous, consisting of multiple nests, and polygynous, containing multiple reproducing queens. Like many social insects, T. sessile employs complex foraging strategies, allocates food depending on environmental conditions, and engages in competition with other insects. 3 for T. sessile can be found in a huge diversity of habitats, including within houses. They forage mainly for honeydew, which is produced by aphids and scale insects that are guarded and tended by the ants, as well as floral nectar and other sugary foods. They are common household pests and are attracted to sources of water and sweets. 3, 5, 6 Tapinoma sessile have long been suspected of exhibiting cloning behaviors similar to those observed in Black Sea Rhazy ants. This hypothesis has recently been confirmed through experimental evidence. In a notable experiment conducted by Marcello Ponzo, a colony consisting of 7 queens and approximately 3,000 to 4,000 workers was kept in a controlled outworld and nest environment after being capped, lured from the wild. Within a period of almost 2 months, the colony increased its number of queens from 7 to 10 under optimal conditions and a nutritious diet. This observation provides strong evidence supporting the theory of cloning in Tapinoma sessile. Like most other ants, T. sessile is eusocial. This is characterized by reproductive division of labor, cooperative care of the young, and overlapping generations. 6, 7. Etymology of binomial name Tapinoma sessile was assigned by Thomas Say in 1836. Sessile translates to sitting, which probably refers to the gaster sitting directly on top of the petiole in the abdomen of the species. 8. The common names odorous house ant and coconut ant come from the odor the ants produce when crushed, which is very similar to the pungent odor of a rotting coconut, blue cheese, or turpentine. 1. In entomology, petiole is the technical term for the narrow waist of some hymenopteran insects, especially ants, bees, and wasps in the suborder Apocrita. The petiole can consist of either one or 2 segments, a characteristic that separates major subfamilies of ants. Structure at term petiole is most commonly used to refer to the constricted first and sometimes second metasomal posterior segment of members of the hymenopteran suborder Apocrita ants, bees, and wasps. It is sometimes also used to refer to other insects with similar body shapes, where the metasomal base is constricted. The petiole is occasionally called a pedicel, but in entomology, that term is more correctly reserved for the second segment of the antenna. 1. To Wallenarachnology, pedicel is the accepted term to define the constriction between the cephalothorax and abdomen of spiders. The plump portion of the abdomen posterior to the petiole and postpetiole in the Myrmicinae is called the gaster. 3. The structure of the petiole is an easy way to visually classify ants, because the major subfamilies of Formicidae have structural differences. Some ants have 2 segmented petioles, while others have a single segmented petiole. For page needed, certain wasps also possess a 2-segmented petiole. notably extant wasps of the family Mimoromatidae. 5. The fossil taxon Rasnitsovania preolacidae has a two-segmented petiole. 6. Description: sessile is a small ant that ranges in color from brown to black and varies in length from 116 to 1/8 inches, 1.5 to 3.2 millimeters. When crushed, these ants leave a smell, which leads to their nickname stink ant. 1, 5, 6. The gaster portion of the abdomen sits directly on top of the petiole in the abdomen of this species, which helps distinguish them from other small, dark, invasive ants. 8. A comparison of the side view of T. sessile below and a diagram of the atypical ant body below shows how T. sessile's gaster sits atop its petiole. This leads to a very small petiole and to the gaster being pointed downward. The anal pore then opens ventrally toward the abdomen instead of distally. 8. Their antennae have 12 segments. 6. Antennae SG. Antennae, sometimes referred to as feelers, are paired appendages used for sensing in arthropods. Antennae are connected to the first one or to segments of the arthropod head. They vary widely in form, but are always made of one or more jointed segments. While they are typically sensory organs, the exact nature of what they sense and how they sense it is not the same in all groups. Functions may variously include sensing touch, air motion, heat, vibration, sound, and especially smell or taste. 1, 2. Antennae are sometimes modified for other purposes, such as mating, brooding, swimming, and even anchoring the arthropod to a substrate. 2. Larval arthropods have antennae that differ from those of the adult. Many crustaceans, for example, have free-swimming larvae that use their antennae for swimming. Antennae can also locate other group members if the insect lives in a group, like the ant. The common ancestor of all arthropods likely had one pair of uniramus, unbranched antenna-like structures, followed by one or more pairs of biramus having two major branches, leg-like structures, as seen in some modern crustaceans and fossil trilobites. 3. Except for the chelicerates and protorans, which have none, all non-crustacean arthropods have a single pair of antennae. 4. A side view of the body of T. sessile. It shows that the gaster part of the abdomen is directly above the ant's petiole. A diagram showing the names of the different sections of a typical ant's body. Note that the petiole in this typical ant is in front of the gaster, rather than under it. The antennae of T. sessile has 12 distinct segments that queens lay the eggs, which incubate between 11 to 26 days. After hatching, the larval stage lasts between 13 to 29 days, and the pre-pupal and pupal stages last between 10 to 24 days. 6. Little is known about the lifespan of the ant, though it has been shown that queens live at least 8 months and probably much longer. Workers at least a few months and show every indication of living as long as queens, while males appear to live only approximately a week. Distribution. Sessile is native to North America and ranges from southern Canada to northern Mexico, but is less common in the desert Southwest. 6. North America is a continent B in the northern and western hemispheres. C. North America is bordered to the north by the Arctic Ocean, to the east by the Atlantic Ocean, to the southeast by South America and the Caribbean Sea, and to the south and west by the Pacific Ocean. The region includes Middle America comprising the Caribbean, Central America, and Mexico, and Northern America. North America covers an area of about 24,709,000 square kilometers, 9,540,000 square miles, representing approximately 16.5% of Earth's land area and 4.8% of its total surface area. It is the third largest continent by size after Asia and Africa, and the fourth largest continent by population after Asia, Africa, and Europe. As of 2021, North America's population was estimated as over 592 million people in 23 independent states, or about 7.5% of the world's population. In human geography, the terms North America and North American can refer to Canada, Greenland, Mexico, St. Pierre and Miquelon, and the United States, or alternatively, Canada, Greenland, and the United States, Mexico being classified as a part of Latin America, or simply Canada and the United States, Greenland being classified as either Arctic or European. Due to its political status as a part of the Kingdom of Denmark, the same goes for St. Pierre and Miquelon in relation to France, and Mexico being classified as Latin American. 7, 8, 9, 10, 11. It is unknown with certainty how and when first human populations first reached North America. People were known to live in the Americas at least 20,000 years ago. 12, but various evidence points to possibly earlier dates. 13, 14. The Paleo-Indian period in North America followed the last glacial period and lasted until about 10,000 years ago when the Archaic period began. The Classic stage followed the Archaic period and lasted from approximately the 6th to 13th centuries. Beginning in 1000 AD, the Norse were the first Europeans to begin exploring and ultimately colonizing areas of North America. In 1492, the exploratory voyages of Christopher Columbus led to a transatlantic exchange, including migrations of European settlers during the Age of Discovery and the early modern period. Present-day cultural and ethnic patterns reflect interactions between European colonists, indigenous peoples, enslaved Africans, immigrants from Europe, Asia, and descendants of these respective groups. Europe's colonization in North America led to most North American-speaking European languages, such as English, Spanish, and French, and the cultures of the region commonly reflect Western traditions. However, relatively small parts of North America and Canada, the United States, Mexico, and Central America have indigenous populations that continue adhering to their respective pre-European colonial cultural and linguistic traditions. Behavior colonies vary in size from a few hundred to tens of thousands of individuals. Big colonies usually have multiple queens. 6. The odorous house ant is tough. Injured workers have been observed to continue living and working with little hindrance. Some queens with crushed abdomens still lay eggs, and there are documented instances of sessile queens surviving without food or water for over 2 months. They also appear highly tolerant to heat and cold. These ants are difficult to remove from a home after their colony has become well established. 5. When offered a choice of food sources, the ants preferred sugar and protein over lipids, and this preference persisted in all seasons. When specific sugar sources were studied, the ants preferred sucrose over other sugars, such as fructose or glucose. 3. Food allocation. Foragers collect food that is around the nest area and bring it back to the colony to share with the other ants. Sessile has polygamous colonies, meaning that one colony has multiple nests. Because of this, sessile is very good at foraging for food when there is great variance in the distribution of resources. Instead of going back to a faraway nest to deliver food, they move workers, queens, and the brood to be closer to the food, so that they can reduce the cost and effort of food transport. This is called dispersed central place foraging. 2. It was also found that the half-life of the stay at any one nest was about 12.9 days. 9. Butchkovsky and Bennett also studied the pattern of food movement within a nest. They labeled sucrose with immunoglobulin G proteins and then identified them using an enzyme-linked immunosorbent assay ELISA to track the movement of food. They found that food was spread through trophallaxis, one animal regurgitating food for another. Despite this trophylactic spread of food, the workers kept most of the sucrose. They also found that some queens received more food than others, suggesting a dominance hierarchy even between queens. They also found that the nests were located in a system of trails, and that their distribution depended on where food was found and the distance between these patches of food. 2. It was also found that the rate of trophylactic feeding depends on the number of ants per nest and the quality of food available. When the number of donors is kept constant, but the number of total individuals is increased, more individuals test positive for the food marker. This indicates that more individuals are eating, but the amount they eat is less. If the number of donors was doubled, and the size of the overall population increased, the number of individuals receiving food more than doubled, again indicating that the number of individuals fed increased, but that the per capita amount of food consumed decreased. 10. When searching for food. Primary orientation is when ants are exploring a new terrain without the guide. Secondary orientation is when terrain has been explored, and there are pre-existing odor trails which ants use to orient themselves. When sessile ants are orienting themselves for the first time, they often rely on topography. The major types of elements they rely on are bilaterally elevated, bilaterally depressed, unilaterally elevated, and unilaterally depressed. They use these types of surfaces to orient along and lay the first odor trails, which can then be followed in the future to the food source by other ants. 11. Seasonal behavior. It was also found that this ant species practices seasonal polygamy, having multiple colony sites to have access to multiple food sources. The colony will overwinter in a single nest, and then during spring and summer, when resources are more abundant, they will form multiple nests. This allows them to better use food sources that might be spread out. During the winter, they will return again to the same nest location. Seasonal polygamy is rather rare and only found in 10% of all polygamous species. 12. Seasonal polygamy is not found in many ant species, but there are many ant species, including sessile, which move within a season. Migration to better forage sites is common. 9. Seasonal activity patterns of the ants were also studied, and corresponding to the seasonal polygamy, it was observed that the ants displayed the most activity between March and September and displayed almost no activity from October to December. Daily activity patterns were also studied. In March, sessile foraged during the day, but in April, that pattern changed and the ant began to forage during both day and night. During most of the summer, sessile shows low levels of activity throughout the day and night. 13. Competition with other ants. Competition between species is often classified as exploitation or interference. Exploitation involves finding and using limited resources before they can be used by other species, while interference is the act of preventing others from getting resources by more direct force or aggression. When it comes to these behaviors, the species is considered dominant if it initiates an attack and subordinate if it avoids other species. In comparison with 8 other ant species, sessile was more subordinate on the dominant to subordinate scale. The ant does not show a large propensity for attack, preferring to use chemical secretions instead of biting. For when sessile, the subordinate species, was in the presence of dominant ant species such as C. ferrugineus, verification needed. P. imparis, Lasius alinus, and F. subseritia, they reduce the amount of time spent foraging. This was tested with the use of bait, and when the subordinate species, such as sessile, encountered a dominant species, they would leave the bait. It would then make sense that the subordinate species would forage at a different time than dominant species, so that they could avoid confrontation. But there is sizable overlap in foraging period on a daily and seasonal basis, because sessile forages at the same time as dominant species, but avoids other foraging ants. They must have excellent exploitative abilities to survive. 13. One of the invasive species that sessile has had to contend with is the Argentine ant, Linapitheme ahumal. Studies of its interactions with L. humal has helped researchers better understand the aggression of sessile. Sessile ants rarely fight alongside their nest mates. They only were observed to have fought collectively in 6 of 40 interactions. This often caused sessile to lose altercations with other ant species, such as L. humal, even when more sessile individuals were present. Whereas other ant species, like L. humal, fight together, sessile do not. Sessile is, however, more likely to win in one-on-one interactions because they have effective chemical defenses. 14. Other habits. This species is a scavenger, predator ant that will eat most household foods, especially those that contain sugar, as well as other insects. Indoors, they will colonize near heat sources or in insulation. In hot and dry situations, nests have been found in houseplants and even in the lids of toilets. Outdoors, they tend to colonize under rocks and exposed soil. They appear, however, to form colonies virtually anywhere in a variety of conditions. In experiments where T-sessile workers were confined in an area without a queen, egg laying by the workers was observed, though the workers destroyed any pre-pupa that emerged from the eggs. 5 odorous house ants have been observed collecting honeydew to feed on from aphids, scale insects, and membricids. They appear to be more likely to invade homes after rain, which washes away the honeydew they collect. Odorous house ants appear to be highly tolerant of other ants, with compound nests consisting of multiple ant species that included T-sessile having been observed. Predators and parasites, some birds and toads will eat odorous house ants on occasion. Wheeler 1916 mentions Bothria myrmex damotsky as a possible parasite of odorous house ant colonies, suggesting that B. damotsky queens invade and replace T-sessile queens. Isobrachium myrmecophilum, a small wasp, appears to parasitize odorous house ant. Pest control. Sessile are not hard to control. They are vulnerable to most ant killers, which are especially effective when applied as soon as their presence is noticed. If dealt with early, their numbers can be brought under control in just a few days. However, the longer a colony is ignored, the larger the population becomes and the longer it will take to clear the infestation, possibly a few weeks. 5. These ants most commonly invade buildings in late winter and early spring, particularly after rain, at which times one should be on the lookout for newly arrived ants foraging indoors. 6. 9. To discourage immigration, standing water should be eliminated in the house, as T-sessile are attracted to moisture. 3. Plants should be trimmed away from buildings, so they do not make convenient routes for above-ground entry. Cracks, holes, and joints should be sealed with polyurethane foam or caulk, especially those that are near the ground. Firewood, rocks, and other materials should not be stored next to a home because it provides sites for nest building one near the home. And T-sessile naturally relocate their colonies to be near successful forage sites. Thanks for watching.